Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to take a brief look at parent functions. Now, chances are you've seen these parent functions used many different times in the past. Best way to think of them is the proud papa of all the stuff that comes. So, let's say we take a look at, and let's make ourselves a little table here. So, let's make a table and label this with function. Then the papa, or the parent, papa, daddy, it's a proud papa too, and a sample child. So, whenever we say function, so there's lots of different types of functions. So, the first function, people should be very familiar with this, and that's a linear function. Linear functions are those things that are just straight lines. They look like mx plus b. So, for example, f of x is equal to x is the parent. And actually, let's make ourselves a last one. And this is what it looks like. Because I myself am a nice visual learner, and I like you guys to see this as well. So, if f of x is equal to x is the papa, the daddy, then what's a sample child? Well, f of x is equal to x plus 2. This is made using the x. So this is an example of a child that this papa would make. And you can mix this any way you want. You can do 2x plus 3, 1/2 x minus 2, all this kind of stuff. All looks the same. So, what does it look like? Well, it's a straight line. And that's linear. Now, each one of these things have their own properties, and we're going to talk about those in a bit. Next up, quadratic. Quadratic is a bit more exciting than linear. So the proud papa would be x squared. So sample child would be something like 3x minus 2 squared minus 5. I can make it as complicated as possible, but the second you see a squared and an x, it all came from this guy. And what does it look like? Well, it can either look like this, like a U, or an N. Just like with my line, I can either look like that or like this. All right, and that all comes down to whatever my a value is, so the number beside the x. So if the number beside the x is positive, it goes up like that. If the number beside the x is negative, it would go down like this. Same thing here. If the number beside your x is positive, then it looks like this. If it's negative, it looks like that. All right, next up, we've got the radical. The radical, he's like the rebel of the family. He just wants out every single time. All right, and the radical, well, what's papa look like? Well, the papa looks like this, square root of x. So what's sample child? Sample child would be something like 2x plus 3 minus 1. Again, does not matter all the hoopla that's around. As long as you say a square root and an x, it comes from root x. Now, square root of x is basically the opposite of the x squared, so because of that, it's basically half of a parabola. Flipped upside down like that. That's if it's plus, and that's if it's minus. Let's keep snipping. What else do I got? I've got a reciprocal. Now, running out of colors. Reciprocal. Too many daddies here. Well, reciprocal looks like this. All right. What's an example? Well, here's an example child. All right. Now, these usually have what we call asymptotes, and you saw those from other videos we talked about them. So asymptotes, I'd actually need to draw my grid here, so if I draw my grid, well, generally it looks like this. You'd have can't touch this, and that's how they usually look like. And finally, my last function we're going to talk about is the absolute value. I'm going to use this as white here, absolute. What does that look like? Well, f of x is equal to, got your x, and 2 bars. So for example, let's say you have negative x plus 1 plus 7. Okay? So what do we know about this stuff? Well, I'm going to make myself another column here. I'm going to name this domain and range. All right, so in this column, let's take a look. Let's start with linear. Now, when you talk about domain and range is basically, for domain, is there anything x can't be? And for range, is there anything y can't be? We're going back to our domain and range video from earlier. Well, for a linear line, x and y can be everything you want. So for domain and range, x is an element of the real, and y is an element of the real because they can be everything. For quadratic, well, x can still be everything, but range is either going to be y is greater than or equal to 0, or y is less than or equal to 0. That depends on your a value. Basically, if you get the U shape or the N shape. Now, if I have the U shape, then this point here, remember our vertex, would be called a minimum. This one would be called the maximum. As for radicals, we cannot take the square root of a negative number. And because of that, that literally tells you all you need to know for your domain and range, which is that my domain has to have x being greater than or equal to 0, because I can't have a negative, which also means I'm never going to get a negative y. So y also has to be greater than or equal to 0. Next up, reciprocals. Now with the reciprocals, we cannot divide by 0. And because we can't divide by 0, whatever your bottom is, again, this is all for the papas, then I would have the x cannot be 0, but it could be everything else. As for range, well, 1 divided by a number. Am I ever going to divide it by a number that gets me an answer of 0? Never. And that's why y can also never be 0, but could be everything else. And finally, let's take a look at the absolute value. In the absolute value, X can be everything. Doesn't really matter. X is definitely everything. And I just realized I did not tell you how this looks like. Well, an absolute value looks like this. Now, what makes this different than a parabola? Well, notice this sharp edge here. This is more like a V shape rather than a U shape. All right? And as for range, well, range is everything, but has to be greater than or equal to 0. Now, why is it greater than or equal to 0? Because an absolute function, if a negative is in there, it comes out positive. So the absolute value of negative 2, I'm going to write an example. Absolute value of negative 2 is equal to 2. So comes in negative, comes out positive. Squeaky clean. All right? And that's it. Those are the properties of parent functions and what sample child look like. We're going to use this later on to show you how we can use this for transformations, but it's very important that you understand what they look like initially so that you can understand what they turn into after we transform. Have yourselves a great day and enjoy!